Section 7.1 and 7.2 were quite frankly a quick algebra review for the most part of exponential and logarithmic functions we should have learned about multiple times. Now we need a new breed of function called the hyperbolic function. These functions will be particularly useful for physics, engineering, architecture, fluid dynamics, and such. So they actually have a ton of physical applications and uses, but they're not a function that you've seen before. They're a new type of function. Now they're kind of similar, or they're similarly derived to the regular trigonometric functions. So let's remind you about those. So this is the graph of the circle. It's called the unit circle because its radius is 1 and uni means 1 in Latin. So the unit circle, right, is x squared plus y squared equals 1. And what you do is you have an angle that cuts off an arc and a sector of that circle. Now the arc and the angle are actually the same as long as you're talking about radians. That's what radians is. Radians is saying, hey, how many radii would this angle section off on this circle? Right? So the angle and the arc are one and the same. That's kind of a way you can view radian measure, if you will, of angles. Although radians aren't really a measure, but there you go. Now the area of that sector is t divided by 2. Right? It's just how it would work in a circle. All right, so what they decided was, hey, we don't have to just do this in a circle. We could also do this on a hyperbola. So suppose you have that area, here let me turn off the hyperbola for a second. So you have this area of a circle, here's your unit circle, and if I let this angle flow, right, around, the angle and this arc length along that circle are one and the same. So what they thought was, hey, we also have a hyperbola that would touch on that circle. Similar formula, it's just minus y squared instead of plus y squared. And it's a unit hyperbola because it's out 1 unit from the origin. So it's called the unit hyperbola in many circles. So then look at the hyperbola point and the area of the sector it creates. So what happens is that the blue area and the red area are the same, but they're on different curves, so they have different values. So if I were to label these points versus these points, so you can see the labels right there. Completely different numbers, right? Completely different. So the red ones here for the circle are cosine and sine values. So this point right here is giving you the cosine and the sine. But these points up here for the hyperbolic point, those are numbers too. So what do we call those? And they're like, I know, we'll call them hyperbolic cosine and hyperbolic sine, cosh and sinh. And so that's what they named them. So if we go back to the notes, that's what they're doing. So hyperbolic cosine, hyperbolic sine. They put a little h after them, right? Because they're totally different numbers, right? They're not really related to the unit circle per se, insofar as it's derived the same way that the unit circle is derived. That's where they come from. So this is a value totally separate from cosine, really has nothing to do with cosine. And this is a value that's totally separate from sine. Where the relationship happens is just that the area of sectors would be the same. Right? The red zone on the unit circle and the blue zone on the hyperbola are one and the same. Fascinating, huh? All right. So that creates a whole new set of functions based off of the unit hyperbola. Unit hyperbola because it touches at the 1 value. So that's why it's the unit hyperbola. And that area is t divided by 2. So I don't know why the book wrote it this way. So I can just write area equals t divided by 2. It's the same area here as it is on the unit circle. That's the relationship. All right, so this creates a whole new class of functions, the cosh and sinh and so on. So let's look at some of them. Now I have them here defined and drawn for you. I believe they're actually on the quick reference sheet as well. Hyperbolics are the kind of thing that, unless you're in an upper level mechanical engineering class, we're not going to memorize them. We're just getting comfortable with them. So all these graphs are actually on your quick reference sheet as well, because you're not really expected to memorize them so much as be able to use them. They all have separate domains and ranges, and I also have Desmos graphs posted for you as well, so you can kind of look at each one of them. Oh, not that one. They're in here somewhere. There, this one. So you can look at cosh. That's what cosh looks like. This is what sinh looks like. This is what tanh looks like. Tanh, hyperbolic tangent. Hyperbolic cotangent, coth, coat. And then seksh. And then coseksh. Yes, that's really how people say them. But you can say hyperbolics if you want all the time, but that gets annoying. So coseksh and seksh and koth. Actually, that one I've usually heard coach, but you know, whichever way. I mean, none of them are real. You're just making them up. So actually, sinh and cosh, those ones we use a lot. So there they all are. Different functions, completely different functions than cosine and sine. And they actually have algebraic interpretation as well. And it says it right here, but I'm going to prove it to you in Desmos. So in Desmos, if you want to click on this, you can see I actually have the graph of y equals e to the x plus e to the negative x over 2. And you can see that is the same graph, right? They are one and the same. If I turn that one off, let me go grab, I don't know, seksh. So seksh is 2 divided e plus e to the negative x. Yep. Right, that is the algebraic way to write that. So all of these actually also have an algebraic interpretation or algebraic function as well. They're just kind of tedious. These get used so much in certain engineering fields that they were named their own names. And again, it's related to the hyperbolas and the unit circle. They are, in fact, do have the reciprocal identities. So coach is 1 over tanh, seksh is 1 over cosh, and coseksh is 1 over sinh. So in case you're interested, that relationship does still hold. Again, you were also given a bunch of identities on the sheet, so you don't have to memorize any of that. So I have 1 over tanh right here and all of that good stuff. Right, so that's all written there. They also have restricted domains and ranges in order to make them one-to-one for a couple of them, in particular seksh and cosh, I believe. So in order to make them one-to-one so they have inverses, that happens. And then there's a bunch of identities, which we'll talk about in another page, but there they are. All right, so then, talk about right in the next page. That's where they are. Okay, so let's look at some of these identities. So it's not quite the Pythagorean identity. It's similar. It's the cosh squared minus the sinh squared is equal to 1, amazingly enough. Cosh of negative x is equal to cosh of x, which by the way means cosh is even. Sinh of negative x means equals negative sinh of x, and tanh of negative x equals negative tanh of x. So those two functions would be odd, which you can see. Cosh, when you look at it, that's an even function. Tanh, when you look at that, is an odd function. It's symmetric around the origin, as is sinh. So we can actually say that cosh is an even function, and both of these are odd functions based on the definition of even and odd. Symmetric with respect to the y-axis, symmetric with respect to the origin. These are kind of the modifications of the Pythagorean identities. So these are the Pythagorean identities for hyperbolic functions. Then you have a sum, a couple sum identities, a double angle identity, and essentially a half angle identity, right here. Right, that's what all those rows are. Okay, so we're going to prove that cosh x, or cosh squared minus sinh squared equals 1. I mean, it's the base fundamental Pythagorean identity, so we're actually going to prove that it's true. All right, just in case you don't believe me. All right, so cosh squared minus sinh squared. So cosh squared x minus sinh squared x is the same thing as cosh of x squared minus sinh of x squared. Make sure you put that h in there. That would be equal to, and then each of these has a function. So cosh is e to the x plus, I can't remember it. Yeah, plus e to the negative x over 2. Sinh is e to the x minus e to the negative x over 2. So I'm actually going to substitute in those values. So this is e to the x plus e to the negative x over 2 squared minus e to the x minus e to the negative x over 2 squared. Okay, so that would be e to the x plus e to the negative x squared over 4 minus e to the x minus e to the negative x squared over 4. Actually, write those out because we want to FOIL those. Give me 1 second. There, since I'm going to have to FOIL them, we might as well write it out. It'll make it easier because this is going to be tricky. Now you'll notice they both have a fourth in them. So I have every intention of factoring a 1/4 out of all of this. That'll just make things easier. All right, so e to the x times e to the x is e to the 2x. And then I have an e to the x times an e to the negative x. But e to the x times e to the negative x, we would add 1, or add x plus negative x, which make e to the 0. We'll get there. And then we have an e to the negative 2x for that one. Minus, and then it's going to be very similar. E to the 2x minus e to the x, e to the negative x. Actually, 2 of them. I take it back. There's 2 of them because there's an outers and an inners. And then plus e to the negative 2x. Now, keep in mind, e to the x times e to the negative x would be e to the x minus x, which is e to the 0, which is 1. And that would happen here as well. So that means that I have a fourth out in front. Then I have an e to the 2x plus 2 plus e to the negative 2x minus e to the 2x minus a minus 2, which is plus 2, and then minus an e to the negative 2x. And hopefully you're seeing what I'm seeing. Because e to the 2x minus e to the 2x is gone. E to the negative 2x minus an e to the negative 2x is gone. And I'm left with 1/4 times 2 plus 2, which is 4. Which last time I looked is 1. And we have verified this identity.